and another thing that I found interesting was about this idea of the division of labor.
Mm-hmm.
And if you look at the history of civilization, like you can see like people specializing in something. That helps explain the idea of progress in a way. But in the past we talked to this business professor, Dr. Torelli, and he's written many articles and books on the idea that specialization is not enough because we've made so much progress in different fields that it's really hard, even if you have a PhD, it's really hard to make progress in such field. So going back to the idea of coordination, how can we, like this idea of like, how can we, I guess in a sense is I guess what I wanted to ask is that, given what you learned from instincts when you were learning about, like the idea that learning comes from instincts.
Mm-hmm.
Like how can we given what you learn, how can we learn more about this idea of like specialization and finding out what we truly instinctively are good at?
Mm-hmm. Yeah, so that's a fascinating question, and honeybees are a great model to be looking at to illuminate that question, because honeybees have a great balance of specialization, division of labor, and flexibility. So let me explain a little bit about the division of labor in honeybees. So adult worker honeybees live about 6 weeks. They spend the first 2.5 to 3 weeks working inside the beehive, and then they graduate and become foragers, and they work outside the beehive. So when they're inside, the first 2.5 to 3 weeks, they progress through a series of different jobs, and they specialize on those jobs for a few days for each one. Then they make that, so those are a series of transitions. Then they make the biggest transition from working in the hive to foraging. So foragers, what they do is when it's nice weather and there are flowers, they go out and make trips back and forth to look for flowers, to find them, and then collect nectar and pollen, bring it back to the hive. That transition usually takes place, as I said, between 2.5 to 3 weeks of age. Now, if something happens to the colony, for example, if they lose many or most or all of the foragers in the colony, predation, some kind of accident, pesticide poisoning, so forth, the colony is now in a situation where it's sort of like you cut off its head. So what happens? Does the colony just sit there and die? No. There's plasticity. Some of the young bees that would otherwise be working in the hive, doing jobs in the hive, they accelerate their maturation and they become precocious foragers. They start to forage at an age younger than what they would normally. Likewise, you can have a situation where, again, you have a division of labor. You've got young bees working in the hive, old bees foraging, and something happens to the young bees in the colony. So some of them succumb to a disease of some kind or another, leaving very few. Then you can have two things happen. One, some of the remaining young bees can delay their maturation. They can slow it down so they become over age at what they're doing, nursing, taking care of the baby bees. Rather than grow up, graduate, become a forager, they slow their maturation down. And then the most extreme version is you can have foragers that have already, bees that have already graduated, have already become foragers. They can actually revert, become young again, and take over the jobs that young bees do. So they have their roles, but yet there's plasticity in their roles. And then the question arises, and that is, well, how do they know what to do? So as in labor markets, as in the economy, as in the stock market, as in grains of sand in an avalanche, there's no centralized control. There's no direction, central direction. The queen doesn't tell the bees what to do, but instead, individuals pick up local signals, and then those local signals have evolved to convey global information, again, in a kind of automatic way. So we studied this process extensively a number of years ago and found that the way it works is older bees, foragers, produce a chemical, and those chemicals are called pheromones, that affects the behavior of other bees in the colony in a very particular way. It delays the maturation of the young bees. So when you think about it, the more foragers that are there, the more of this inhibitory chemical is produced and circulating among the bees. So the young bees are inhibited from growing up, and so you have a nice division of labor. You remove the foragers, you're removing this inhibition, some of the bees will mature rapidly because they don't have this inhibition, and so on and so forth. So this pheromone and the circulation and the distribution of the pheromone can explain how you see plasticity as well as then specialization. And then now what we know is that this pheromone affects the activity or the expression of genes in the brain to orchestrate the right behavioral state.